Hey everyone, welcome to the show. This is Darren with Genfinity. Today we have a group of builders from the ICP ecosystem. I wanted to start off with just introductions and just tell us about your projects and what your project is and kind of how you got into crypto and all that stuff. So I want to start off with Matt.
Yes.
Sorry,
Yes. Yeah. No
Matthias.
worries. Yeah. So first off, my name's Matthias Rask, and I'm the founder of Magic Swap on the Internet Computer. Basically, Magic Swap makes trading easy on an internet computer by allowing you to utilize a suite of trading tools such as charts, liquidity charts, and a built-in DEX aggregator that allows you to swap with different DEXs on the internet computer. Our platform is completely non-custodial, so we don't manage your tokens at all. They go directly to the DEXs. I started back on crypto back in 2017, I want to say, on the Ethereum network, back during like the first big boom with Bitcoin when everything was rallying up to, I believe, like 23,000. And over time, I jumped from different chains and I eventually settled on the internet computer back in 2022, around like November, I'd say. And that's when I really started getting interested in development, particularly on this platform, due to the technology that I had noticed when I was trading on it. I thought that it was absolutely incredible. Not needing to pay gas, instant transactions, basically. Yeah, it's really great.
Jordan, can you tell us about your intro and how you got to work on your project?
Sure. My name is Jordan Last. My company is called Demergent Labs. We're building open source developer tools for ICP. So our whole goal is to basically bring Web 2 technologies to Web 3. So TypeScript, JavaScript, and Python, we're bringing those to ICP so that people can use regular, normal languages that they're already familiar with to develop on the internet computer. The goal is to allow people to npm. If you're a dev, you'll understand this. Npm install any package and let it run on ICP. Pip install any package and let it run on ICP. And some of the stuff we're doing is also going to make it easier for Rust and C++ to be able to pull any package off the shelf and just get it to run. So that's what our project is. I studied computer science. I've always loved the web and the internet and JavaScript, and just the power that those technology, like the creative and expressive capabilities that they give people. And so I entered the crypto space in 2017. After learning about Bitcoin enough times, I decided to actually look into it. And that led to Ethereum. And all that led to finding Definity, the foundation that created ICP, around the same time in 2017. I've been following the project ever since. And I fell in love with the world computer vision and the idea of a virtual machine that could scale without bounds. So that's what I'm hoping ICP can become.
Awesome. And Bob, can you talk about your project and your intro?
Yeah, sure. So we are building Bitcoin infrastructure and Bitcoin tooling, and we're leveraging all of the unique protocol primitives that we have on ICP. We have threshold signing with the threshold signature subnets. We have a wrapped version of Bitcoin called CKBTC. We've also done the same thing with ordinals. And then we also have a Bitcoin Light node that's running fully on chain on ICP. So you can get Bitcoin balances or you can get the UTXOs held in a particular address. And so leveraging all of those, you can build some interesting interoperability solutions for the Bitcoin space. And so this is what we've been working on since February 6th of 2023. This was about 2 weeks after Casey released the Ordinals protocol. And Ordinals started taking off, and it was just 2 weeks after that we basically we were convinced that Ordinals were going to be a massive thing on Bitcoin. And so we've been building, leveraging all of the unique Bitcoin tech on ICP in order to support Ordinals, and other unique aspects, kind of bridging these two worlds of ICP and Bitcoin. So yeah, we've been building since February of 2023 on kind of the Bitcoin tech, and before that, we spent a lot of time building other tech on ICP previously.
And it's kind of interesting, right? Because the ordinals were embedded into the chain versus an NFT that's like kind of a pointer to the actual JPEG or whatever. So can you talk about Magic Swap and what sets you apart from different dexes or anything in that area?
Yeah, that's a good question. So rather than Magic Swap being its own DEX, we're taking advantage of being a DEX aggregator. So right now on the internet computer, there's a lack of interconnectivity between the DEXs. So if you want to swap on one DEX, you're going to have to tab out and move to another one. And we want to eliminate the friction between trading between these platforms, excuse me. And by doing that, we want to provide a platform similar to Dex Screener or Dex Tools, the equivalent on internet computer, and host it in a way that's 100% on chain and bring more exposure to the internet computer through the internet computer itself, of course, and cross-chain functionality as well. So that's going to be a big player for us, talking about like CK Bitcoin, stuff like that. We're really going to hammer home, especially for cross-chain users coming into the platform and getting them to be able to take advantage of the lower fees on ICP and the faster transaction times, for instance, without having to constantly bridge over their tokens or deal with a bunch of different wallets, stuff like that.
And I know you have to leave soon, so can you just kind of give us something that you're proud of with Magic Swap since the inception, where we can find you and how we can use Magic Swap?
Yeah, of course. So since starting, we do have another DApp called MCSM, which we are going to be reworking soon to give it sort of a refresh. And it's a platform basically for other token creators to come in and create a verifiably immutable platform to launch their tokens. So far, we've seen well over 50 plus projects come in and start their projects on our platform. So I'm super proud of our community for that and the hard work that everyone's putting in terms of where to find us, you can find us on Twitter at MCS_ICP. You can also check us out on our website at mcs.wtf. The token minter, our DApp, and all the information about the project will be there. So go ahead and check us out.
Thanks, Jordan. Can you talk about just why having Python and TypeScript is important and the amount of developers that use those languages compared to something like Solidity?
Sure. So the whole theory is based on don't ask people to do things that they don't have to do. And it's in this context, it's very much focused on the idea of the massive network effects that programming languages have. For example, C++ has a lot of problems. They've been improving it over the years, but it's been a very unwieldy language to work with. And yet it's been used for something like 50-ish years without a serious competitor until the last decade. Rust, in my opinion, is the only serious competitor to C++ in terms of adoption and future outlook. So once a language gets traction and adoption, that network effect is extremely strong. And I think there's a lot of theories for why that could be. I think it's because as a developer, you spend a lot of time learning a new language, and you actually, I think, somewhat fall in love with the languages. You kind of have a relationship with them. So it's very difficult to get a developer to completely switch ecosystems. At least for me, I don't really like completely switching everything I've done in my career just to jump to a new tech platform. So people do it. So Solidity is a good example of, it does have some sort of success. But if we kind of zoom out, there's only like a few tens of thousands of blockchain developers in existence. There are tens of millions, I think something like 10 to 20 million JavaScript developers and 10 to 20 million Python developers. So together, they're a group that's like 20 to 40 million developers. These developers stand on the shoulders of giants. Both of these languages were started in the 90s. And so that's what it's like 2 to 3 decades worth of expertise, of educational content, and of production use of these languages in many, many different contexts. So the idea is there's a whole lot of benefit to simply making Web3 and ICP in particular just another platform where Python and JavaScript are first-class citizens. And right now, Python and JavaScript are not first-class citizens on any blockchain platform that I know of. There are some others that have enabled JavaScript to some extent. So maybe I'm missing a few, but I've never heard of JavaScript being like the first-class choice. So that's what we want to do, and we're pushing hard. Azel, the TypeScript and JavaScript project, has been around for about 2 years now, and we're going to 1.0 production readiness in the next few months. So yeah, TypeScript, JavaScript will be a first-class citizen on the internet computer, and we hope that Python in the next 2025 will probably be when we can get Python to execute all of this crazy AI and machine learning stuff that's going on. So yeah, hopefully that answered your question a little bit.
Yeah, and to your point, when I was going to school for art, like I had to learn Python and JavaScript to design sites, and for those 3D animations, like for dynamics, fluid dynamics, or fire, or something like that, you would have to code that into it. So I know that there's a bigger pool of developers in those different languages. So Bob, can you elaborate just on like, well, we kind of touched on it earlier about Bitcoin and the inscription part of this, right? They're able to put data onto the chain, but ICP kind of has that primitive already. So like, what are the possibilities of expanding Bitcoin's functionality?
Yeah, so one of the key advantages of ordinals is you have the image that's completely on chain. Like you mentioned, for most NFTs, you essentially just have a pointer on chain that points to some image on IPFS. On ICP, we're actually very familiar with the everything on chain idea. Putting something on Bitcoin is, you could view it as kind of extra secure. People always talk about Bitcoin as a store of value or medium of exchange, and they rarely talk about Bitcoin as the world's most decentralized, secure, censorship-resistant database. You could put an asterisk there, and we could debate that. But if it's not the most, then it's definitely up there. And so, being able to secure your tokens, or secure images, or secure other assets on Bitcoin in a way that is immutable and they're forever, potentially is pretty exciting. And I think that's the promise for creators on ordinals. Is being able to come in and have the permanence of Bitcoin with the assets that you're creating as a creator. And the other kind of main kind of driving force behind ordinals is, look at the NFT market cap on Ethereum, and look at the market cap of tokens on Ethereum, and look at the market cap of Ethereum, and then just project all of that to the Bitcoin market cap size. And it's really easy for someone to look at something like that and think, oh, well, NFTs and fungible tokens and all of these other tooling are going to be massive on Bitcoin because of the market dominance and the market cap of Bitcoin. And so, with all of that driving force behind ordinals, we wanted to find a way to make them more programmable and easier to use, and make it easier for creators to get started, and make it easier for people to do things with their ordinals. Right now, most people just have tokens and ordinals, and they just sit in their wallet. There isn't a whole lot you can do with them. And our goal is to give everyone, lots of things that they can actually do with these assets. So whether it's, dynamically upgrade them over time, or whether it's stake them in some fashion for a token, or whether it's actually play some kind of staking game, or some other kind of idle or incremental game. I think people should be able to take their assets and use them in ways that makes them happy and brings meaning to the assets that they hold.
Thanks. So, Matt, do you have time to go next, or do you need to leave?
Yeah, I hate to say, but I gotta run. But great talk, Bob. I really appreciate you guys having me on.
Sure. Thanks for coming on and telling us about Magic Swap. I'm interested to see what you guys do in the future.
Yeah, of course. Awesome. All right, see you guys.
All right, thanks. So, Jordan, so you mentioned like the whole possibility of having Python, having JavaScript on the ICP chain. Are you having some type of platform? Is there going to be a token involved? Like, how is your project going to incentivize or how is your project going to benefit from bringing JavaScript or Python to ICP?
So yeah, right now the projects are just they're just SDKs basically. So Azel, you install it from npm install Azel. Kybra, you install it off of pip install Kybra. So just two normal open source projects, MIT licensed. There is let's see. There are two possible models we are thinking of. It is possible to, in the future, if we can do things compliantly and legally, and if DUNAs and FIT21 and all these things actually pass, there could be some kind of tokenization model. But I think right now the most conservative thing that we're actually about to launch, so it's actually merged into main. We've written a good amount of tests for it, and we'll probably start testing it live soon, is a protocol that we call open value sharing. And this is what we call an open source native business model, where you don't have to change your business license. You don't have to create a special closed source version or have like a business source license. You can use a normal license like MIT or BSD or Apache. And the idea is that, for example, the JavaScript SDK, when you install it into an ICP application, what we call a canister, what will happen is a small percentage, right now by default it's 10%, of the cycles that your canister uses. On the internet computer, cycles are the unit that is used to pay for all computation network resources. It's similar to Ethereum gas. So you have to pay for everything already in cycles on the internet computer. So what open value sharing will do is it will actually direct 10% of the cycles that you're burning. The 10% of that amount, in addition to that, will be distributed to all of the dependencies of your canister. So open source software is built with many, many dependencies. I think most of our examples have like 200 to 500 libraries in them. So we're building on the top of a whole ton of work that's gone before us. So open value sharing will allow all those libraries to be to have a consistent revenue stream in cycles. So that's our business model that we are going to be experimenting with. And it's an open protocol. It's not specific to ICP. It could possibly work anywhere, but we're going to launch it first on ICP, and it might be the easiest place to launch this. So that's that.
Awesome, thanks. So, Bob, can you talk about? Well, we had this discussion before where we're talking about the different types of encryption. So, Bitcoin has similar encryption to other chains, and that will work. Those chains that have the similar encryption type, they can also have like the CK bridging aspect. Can you just kind of elaborate on that, and like if you have any plans to take on other chains in the future?
Yeah, I think that's a great question. So Bitcoin uses ECDSA signatures. It's just a particular type of signature for the majority of transactions, everything except for pay to Taproot transactions. Those leverage Schnorr signatures. So then you have most blockchains like Ethereum or most Ethereum L2s or even Bitcoin L2s that all use ECDSA signatures as well. Anything EVM is probably going to use ECDSA signatures. And then you have a couple new threshold signature types coming to ICP this summer. I believe Schnorr signatures, there's a threshold Schnorr implementation coming, as well as a threshold ED-DSA implementation. So that's like what Solana uses. Solana, and there are a couple other blockchains that use ED-DSA. So between the threshold ECDSA implementation and then EDDSA coming and Schnorr coming, you almost have full blockchain coverage. I mean, it's maybe 95%. I haven't actually done the calculation, but it's somewhere up there. And this means that you can essentially do any kind of cross-chain integration leveraging these protocol primitives on ICP. And so from our perspective, building with a lot of Bitcoin native assets, we do plan on pushing harder into this interoperability space. If you look at the various interoperability protocols like Layer 0 or Wormhole or Axelar or Particle Network, these are solutions that have looked at the blockchain space and seen that we have tons of user fragmentation and liquidity fragmentation across blockchains, across meta protocols, across token standards, across base layers and L2s. And you don't really have good options right now for interoperability across these protocols. I know people are working on shared sequencing and other solutions on the rollup, kind of ZK rollup side, to try to have these kind of atomic swap like interactions between rollups. But I think we do need these interoperability hub protocols. Wormhole specifically uses a threshold Schnorr. I think it's like a 13 of 19 threshold setup, and that's actually very similar to the threshold implementation on ICP. And so building some kind of layer 0 solution, for us, we would probably start with Bitcoin native assets. Bitcoin assets plus, Bitcoin meta protocols plus Bitcoin side chains plus Bitcoin L2s. That's probably in the near term, specifically one of the directions where we'll push, just to try to bring bring interoperability across the Bitcoin space. And the nice thing is, using this particular model, we're not really restricted. Like, I think we could even do Lightning, the Lightning network. I think we could do other meta protocols on Bitcoin, like RGB or Taproot assets or Counterparty, or all, essentially just pick anything that's been building on Bitcoin, and I think we could find a way to bring it into this interoperability hub layer. So that's something we're very excited about, and we're pushing on in the near term.
I got a question for Bob, Darren. And sorry for hopping in late, guys. That's my fault. Bob, so you mentioned ordinals, and I think, if we look, I think that was like last year, like early last year, whenever is that correct? Like around the time of the launch? And I know one of the things, so one of the guys that we talk to all the time, Patches, is like a developer advocate within like Hedera,
Yep.
and stuff. He hopped on. You probably know Patches.
Yep.
He hopped into kind of the ordinals aspects too, and he's like, look, most of Web3 isn't talking about this. And it's amazing that they're not talking about it, because it launched, and I think it was like $500 million of liquidity, like almost immediately. Where do you see the future of something like, maybe it's not just on Bitcoin, but inscriptions and writing data directly onto these chains? There's obviously probably a ton of use cases that aren't even being thought of or haven't been thought of yet. But where do you see it going?
Yeah, there is this inscriptions meta that has been going around every blockchain. This was more like maybe a year ago, but we had inscriptions on Bitcoin. This was like ordinals and BRC20. Then we had ETH-scriptions where you would actually write the data directly to Ethereum, but you would just post the messages in call data rather than smart contract data. So it was cheaper to just put the data on Ethereum, because you were essentially moving the compute off chain to an indexer. After you had ETH-scriptions, then it was like inscriptions were going to every chain possible. We had inscriptions on essentially every chain. People were finding ways to store messages directly on the blockchain and leveraging these off-chain indexers to get your inscription state. Even data availability layers like Celestia. We saw Celestia come out as a data availability layer to support this kind of modularity thesis on the Ethereum side. And because it's a data availability layer, it's kind of perfect to just throw tons and tons of messages at it. And so this inscriptions meta started on Bitcoin and has since spread to essentially every other chain. And there are trade-offs to doing something at the inscriptions layer rather than just leveraging native smart contracts on Ethereum, for example. But for ordinals, particularly, meta protocols or this inscription meta is just very well suited to Bitcoin. Bitcoin has the most limited compute possibility, because you just have script at the Bitcoin L1 layer, and so being able to move compute off chain on Bitcoin is a huge improvement. I mean, you have some trade-offs, but it's crazy how much you can do on Bitcoin by essentially just having these off-chain indexers to support these meta protocols. So, yeah.
So Jordan, can you you mentioned earlier that that ICPU is one of the easiest to work with as far as implementing JavaScript and Python. I was wondering if you could just elaborate on that.
Yeah, I was saying that it's probably easiest to implement the open value sharing protocol on it, but yes, it's true what you said. So you have to think about it this way. Most of these chains, like Bitcoin and Ethereum and even Solana, because of their architectures, they are extremely limited in the amount of compute resources that they have. So they're very decentralized and relatively robust against many attacks. But the trade-offs they have made are that they have tiny, tiny, tiny amounts of memory, kilobytes to megabytes, maybe. The size of your program in total on Ethereum is something like something very small, like 23 kilobytes or something like that. It's in the kilobytes, I'm pretty sure. Solana, I think, is also small. Even these L2s, they're small. So everything is very extremely limited to get them to be able to inherit those properties of decentralization and robustness that they want. The internet computer has taken a different set of design trade-offs. There's a lot less replication going on. The subnet sizes are relatively small, like 13 to 40. You can think of these as like 13 to 40 nodes or individuals that are participating in like threshold or multi-signature operations on every single computation, essentially. So it's quite a bit different. But because of doing that, we have huge, like 1,000 times more compute resources. We have gigabytes of memory, hundreds of gigabytes of storage space, and gigahertz of computation. So yeah, it's just way more compute resources. There are few chains that give you this amount of computational power. AO is another one that does give you this amount of computational power. Outside of AO and ICP, though, there's nothing really that has taken these design decisions to give you this much compute.
I do know I went to, and I caught before I was able to hop in, I was catching what you were saying for Python and JavaScript. And there's only the two ecosystems that I can think of that do natively deal right now. So Hedera with JavaScript, and Algorand just went native Python. But it was interesting because I went to the PyCon summit because it was like literally like 8 minutes from my house, and I didn't even realize it was going on. And I drove down there, and there was zero, except for Algorand, there was zero blockchain representation. And then I started kind of digging into the weeds and just asking, like, I'm not a dev, obviously, but then learning a little bit about what Python is, kind of used for and in traditional aspects out there in the world. Obviously, millions and millions of developers, and then artificial intelligence, a lot of TradFi and traditional finance stuff for scrubbing data and things like that, as well as I think you mentioned it before I hopped on, machine learning, Internet of Things aspects. So it's almost like wild to me that stuff hasn't come into the blockchain space, because all the same stuff and technology we're talking about in crypto and blockchain digital assets seems to be all the stuff that Python natively is dealing with right now. Like, I'm curious, just from your stance, Jordan, like I asked the dude from Algorand the same question, how to product, like, what's the market opportunity here? And it's got to be wildly big. Like, it's got to be big, I'm assuming, right?
Well, both ICP and AO, the leaders of those two protocols that have huge amounts of computational resources on their blockchains or their decentralized computers, are really going heavy on AI. So they think that there's a huge opportunity. I go to an AI working group basically every week in the ICP community. There's a couple enthusiasts there that are pretty enthusiastic about this. So I think it's just starting. I don't think we understand yet what this means. Like what the most powerful LLMs are very resource heavy, but they're also extremely centralized. So, you know, if decentralized, extremely secure computing is useful for some applications, like right now, product market fit is in financial applications. That's where the product market fit is. If it's useful there, is it going to be useful elsewhere? It's debatable, but probably, I would say probably. Like, you probably want the AI that you interact with, the AI that is possibly making, you know, life or death decisions. You know, let's say it starts controlling electric grids or doing important things in our lives. Software didn't used to control anything important in our lives that could hurt people, but now it controls everything that could hurt people. I imagine AI is going to be the same, and so we probably want the properties that stem from decentralized computation to apply there as well. So I don't know. I think it's unknown, but probably this will be very important.
Real quick, just Darren, and then I'll let you run with it again. But it's like I'm always fascinated with the AI stuff. I think obviously like the Chat GPT moment is kind of the widespread AI stuff. AI has obviously been around for decades, but when you say LLM and the large language models and all of the stuff that kind of goes into these, like, is that kind of where you see the utility of like blockchain kind of playing a role, where like you do have the speed and you can like just test out all these proofs. You have a somewhat of a level of decentralization that kind of comes into play, where like I guess part of that question is like, there's all these kind of seemingly bullshit AI projects that stand up in this space because like of the amount of infrastructure it takes to actually run these models. But yeah, I mean, I guess I'm just curious where you kind of see that intersection as far as how blockchain obviously adds into decentralization and proving out these LLMs, like from like a data provenance standpoint, like making sure the data that's going into the AI models is trusted and has an adequate level of decentralization and all this stuff.
I mean, that's an even different. So there's levels of difficulty in the amount of computational resources you need to do things. Inference, asking an LLM a question and getting a response, is already relatively computationally intensive. So there's only two protocols I know that have a chance at doing that in a decentralized manner: ICP and AO. AO by Arweave, FYI. Training is I think even crazier. So I don't know. I don't know. I don't know how to answer the question because it's so new. All I can say is what I had said previously. If the properties of decentralization that blockchain and decentralized computers are giving to finance, if those properties, you know, transparency, security, hopefully someday confidentiality, we don't have that yet, availability. If security is important for that, why is it not going to be important for AI, which is probably the most sophisticated software that we've ever invented? So I think it's very unknown, but we're entering a new world of a ton of experimentation. So there's nothing out there besides ICP and AO that I know of that are really trying to run AIs with, you know, with some kind of consensus that I know of, at least.
AO, I just Googled that and something came up annoying orange, so a crypto. So I know that's not what you're referring to.
Yeah, it's Arweave has the Arweave ecosystem has like a world computer project as well. So it's called AO, the computer.
Okay, thank you, Bob. I wanted to. I'm thinking that we're talking a little bit in the weeds, and I kind of want to break down for people that are new for the ICP ecosystem, kind of why their bridging mechanism is different than the rest of what crypto has to offer. Usually, we see some type of collateralization model or multi-sig type of situation. Can you just go into the details of like why CK bridging is unique and maybe more secure?
Yeah, sure. So for bridging models, generally you have multi-sigs where essentially you have known entities. Maybe let's say we have 15 people, and then you need essentially you're trusting that set of people to sign for your transactions. A good example of a multi-sig in practice is WBTC on Ethereum. There are billions of dollars locked up in WBTC on Ethereum, and that is a multi-sig. It is federated, like you can't join it if you wanted to. You can't, there's no like decentralized way of adjusting those participants. It's a fixed set of key holders. And so a lot of bridges rely on this multi-sig based technology. On the ICP side, they leverage these threshold signature subnets. So for CKBTC, essentially all of your Bitcoin is going to be locked up in an address that's controlled by this threshold ECDSA subnet. That subnet, I can't remember the exact number. Jordan, is it like 31 nodes?
I think it's 28, and it's a 1/3 out of 28.
Okay. Yeah, so 28 nodes in the subnet. And then you have I guess, more than 1/3 honest assumption.
No,
Is
you
that what it is?
only need 1/3 to sign.
Ah.
So
Yeah, so 1/3 of these participants sign, and that's how you get your signature. And so threshold signatures are kind of like multi-sigs. It's like a really, really good multi-sig. There's key resharing that happens at the protocol layer. You don't have individual participants with like, a plain text private key, for example. And then you also have all of the node providers in the subnet are known. Known meaning we know who they are, we know what their business is, we know, there's like this reputational security model here. And that's similar to if you look at like Wormhole. Wormhole takes kind of a middle chain approach to being like a interoperability hub or layer zero, and they have a um, threshold signature implementation that's very similar to this ICP model, where I think they require 13 of 19 or something like that. And these 19 validators are all well-known validators in the Ethereum ecosystem. And so you have similarly this kind of reputational security model. There are other models, like if you look at SBTC on Stacks, SBTC is coming out very soon on Stacks, and you have it's a there's some economic security built in here because you actually have anonymous peggers who can come in and stake their stacks in order to support the bridging of Bitcoin. So there are various models. Some have economic security, some don't. Some have anonymous permissionless setups, and some do not. Some have this reputational security, and others do not. So it's a whole set of various bridging architectures out there.
I mean, it's certainly interesting, like how many different ideas you come up, and then there's like blends of different ideas that just come out of nowhere. Excuse me, the landscapers came outside, so hopefully you guys can't hear it. I removed the background noise. Jordan, I want to know, like, well, let's say that Python's on ICP, and now, and then Algorand also has Python. Will that be a way to interoperate with different chains if their language is the same?
Well, interoperability between chains is not really at the language level. Generally, these chains are actually executing much lower level operation codes. So it's not going to help there. But what it does help is in developer mindshare and being able to redeploy libraries and tools and maybe even smart contracts that have been developed on another chain. So let's say some Algorand developer comes up with a really cool, I don't know, Schnorr signature, crazy, some cryptographic operation that that is very difficult to implement, and then they abstract it away into a library. it could possibly be used on ICP. So at the language level, it's more of sharing code and stuff like that. At the actual, like, being able to send assets between chains and such, it's not really going to help.
I got a question for both you guys because you're both super technically minded, and I'm certainly not. I know we dig into the weeds a little bit here and ask questions that might have terms associated with them. Doesn't mean we understand how to code. I'm curious from your guys' standpoint. You know, obviously one of the big ticket things that we're seeing over the past couple of years is all the ZK stuff and zero knowledge stuff. I mean, do you think the zero knowledge plays a role in the future with any sort of like interoperability between these ecosystems, where just knowing the minimum viable amount of information about something on one chain could potentially theoretically allow that, you know, aspect of value to be able to transfer over into different chains, things like that? I know it's probably super early for the zero knowledge stuff for a question like that, but I'm just curious your thoughts of where it goes. Because right now I see it all surrounds like identity. We're all talking about digital ID and how it ties into the zero knowledge stuff, but I'm curious where you think that might go towards like interoperability in the future.
I'll take a stab at it first. There is this crazy idea of the ZK future. The ZK future is, let's assume everything happening in the ZK space happens, and it happens quickly, and it happens efficiently and securely. In the ZK future, I think it actually looks very different than what we have today. Because in the ZK future, you can just use zero knowledge to prove that compute has occurred. You don't have to do any kind of like, have many people run some kind of consensus mechanism on some kind of compute. You can just, there's an idea called ZKML where you're doing, rather than having to do all of this, it's essentially just running something and then being able to prove that it was run correctly, rather than having to do other things that might be more computationally expensive. There's also thinking about L2s and L3s on various blockchains. Also thinking about like being able to atomically swap between these blockchains. It just simplifies a lot of things in the crypto space, I think, if we assume that the ZK future is real and it's going to happen. Jordan can give a perhaps more nuanced take.
Yeah, so there's various aspects of ZK. The one that I'll focus on that it's not like the other ones aren't interesting, but this one is very interesting, is more of a, it's not really zero knowledge, it's more of a validation or verification. What ZK or validity proving lets you do is it lets you compress the execution of computation down to a proof. So you can basically compress computation, or at least not really compressing the computation, but you're compressing the fact that the computation happened and that it happened correctly. That's how Ethereum is scaling itself, because now you can do a whole ton of computation and you can compress it down to a proof, and you can submit that proof to the Ethereum virtual machine, which is a single-threaded, megahertz level processor. So it's relatively slow compared to your laptop. It's like 1,000 times slower or more, and all Ethereum apps have to share it. So if you can offload that computation, compress it just to a proof, it makes your system extremely efficient without sacrificing security necessarily. I mean, it's a little bit nuanced. So that is amazing. The fact that you can now, instead of relying on replicated computation for security, it is a very important part of the security of many protocols, including ICP. You can swap it out for a little proof. So, for example, ICP replicates compute at least 13 to 40 times to ensure that it's done correctly. Imagine if you could swap that out for one machine with maybe some backups. You can have a decentralized little backup system going around failovers throughout the world, but you're not relying on them for security. You're not trusting any individual node operator to actually perform the computation correctly. If they did it wrong, then the proof will tell you. And that, I think, is very powerful. Not to mention the identity stuff, not to mention possibly, I don't understand this too much yet, but there are talks about about what Bob was saying, being able to, port assets from chain to chain. So yes, ZK is very exciting.
So I see we're getting close to time, so I just wanted to be respectful of everyone's time, and I wanted to ask what you're looking forward to in the future, whether that's industry wide or project specific. Bob, I'll go start with you first.
Yeah. Imagine all of the cool things that Jordan is working on, improving the developer experience and abstracting away blockchain, making it really easy for any developer to come in with their existing JavaScript or Python knowledge and build solutions on a blockchain, and then smash that together with all of the interoperability innovations happening on the ICP side with these threshold signature subnets, being able to build oracles. And now you have this really interesting mix of this like interoperability hub that integrates essentially all chains. You can bring them all together. It kind of solves this user and liquidity fragmentation problem. And now you have this interface for developers where it's just really easy to build cross-chain applications. You almost abstract away the blockchain in a way to where it's not various blockchains. It's just an internet of blockchains. And now you have, just come in with TypeScript and using a simple, using HTTP requests and simple, blockchain config, you can now essentially just really easily build blockchain applications. This is one kind of exciting version of the future that I think we might be able to achieve, leveraging, the work that Jordan's doing and some of the work that we're doing, kind of on the interoperability developer experience side. So, if I had to paint a vision of the future, it's this Internet of Blockchains idea. I know that's been, used before, but the idea where you can abstract away the blockchains and abstract away on the developer experience side, such that you just come in with JavaScript or TypeScript or Python, pull in the libraries you need, and build really interesting applications in a high compute, high memory, high storage, world computer type blockchain. So I think that's kind of where we're trying to get to. Jordan and I have been friends for a long time. We chat a lot, and so it's not hard for me to smash together our visions and into some fun version of the future.
That's a great answer. Jordan, what are your thoughts?
Yeah, so I'll give two visions. One is a very conservative vision of what I think is pretty sure to happen, and one is the more risky. I'll do the conservative one first. Conservatively, I am very excited for regulatory clarity coming to the United States market, which will set a nice precedent for the whole world, even though the rest of the world is kind of ahead. There's still a lot to be said for the United States deciding something. That's going to be great. Combine that with the fact that stable coins are being adopted across the world. Combine that with Coinbase Wallet adopting passkeys, making it super simple to just have a wallet without downloading anything, having seed phrases or anything. I think the UX of crypto is getting amazing. USDC on Base you can send for free, for example. I think that's just leading into the first truly mainstream world adopted product from crypto, which I think will be stablecoins. And from there, I think we'll just tokenize everything. We'll tokenize stocks. We'll tokenize the stock exchange. We'll tokenize car titles, home titles. We'll tokenize the mortgage industry. I think we're going to just make the world more seamless and more secure with less fraud and less crime. And I think that's going to be pretty cool. I think that all is going to happen. I don't really doubt that. Now, for the kind of crazy risky stuff, I kind of feel like everything I do is extremely risky on the I just don't know if the world is going to play out the way that I think it's going to play out. Having a world computer that all computation runs on, I mean, that's a huge moonshot. So if that happens though, what I imagine as a developer, what my dream is, I can just write the logic of my application. I can just pull in a database like Postgres or MySQL. I can write my logic, just check it, make sure it all looks good, and I can just hit deploy. And after I hit deploy, it's like 100% secure, has 100% uptime, it scales to infinity. That's my real dream. And I don't want to deal with you if you're not technical and if you're not like a back-end dev, you've never dealt with the crazy complexity of one of these centralized cloud platforms like AWS. It is crazy the amount of stuff you have to do that is not just writing the logic of your application to get it to scale, to get it to be secure, to make sure the instance you're on OS is up to date, to make sure you've checked all ports aren't open so that people can just come in and check for vulnerabilities and stuff. So I want to deploy my application and have it just scale to infinity and be 100% secure. That is what ICP's vision is in many ways. And so hopefully that happens.
Yeah, it's interesting when you're what we talked to somebody from Personal Down. That's what he said is that he first started building on AWS and it was too complicated, and he started building on ICP, and so it's much easier to build on ICP. The other thought I had was when you're describing the mesh of different blockchains, making the World Wide Web of value. It's like, I'm thinking of like Microsoft front page when you first started making websites, and the one that Adobe had, like people started making things from those types of applications. But so I want to know if there's anything that we missed, and where can we find you and learn more about your projects? Start off with Bob.
I am at Bob Bodley on Twitter. You can look at Bionic Market at Bionic Market on Twitter, where we post everything regarding the ordinal solution that we have, Marketplace and Launchpad right now. That's the best place to just stay up to date. And going to be a pretty big summer, I think, for the cool things we have in store.
Awesome, thanks. And Jordan?
LastMJS is my handle basically everywhere, and my company is called Demergent Labs. You can also find Demergent Labs on X, but everything we do is basically on GitHub and available there. So github.com/lastmjs or github.com/Demergent Labs. And yeah, if I guess the final thing I'd like to say is, if you're interested in building using TypeScript or JavaScript or Python for a decentralized computer in the Web3 environment, our projects are live now. They're both basically pretty mature betas, and the TypeScript and JavaScript one is about to move to a production-ready state for the IC-specific APIs. So you could build your ICP applications and canisters with a lot of security guarantees. So yeah, that's the last thing I'd like to say. Come on over and try it out.
We'd love to get you guys back on, Bob and Jordan, both you guys, to share screen and go through your platforms too. That's pretty cool to do on these spaces, Bionic, and then from the Demergent Lab standpoint too. Sorry, Darren, go ahead.
No. And I just wanted to thank everybody for taking their time. I know Bob's helped me a lot, kind of introduced me to the ecosystem, made himself available. I really appreciate, everybody's time and the help and everything. So thanks everybody. I hope you enjoyed the stream. Bye.